Okay, some questions on limits. They're in the worksheet. I'll read each question and then we'll do. There's like 6 questions in the worksheet. So first question, limit x tends to 0 root of 1 plus x minus root of 1 minus x whole divided by x. Okay, so we have to find the value of this limit. So the question is limit x tends to 0 root of 1 plus x minus root of 1 minus x divided by x. Okay, so we see roots here, and we know for any limit question, first you have to directly substitute the value. That was our first method of solving limit, and then check whether it is 0 by 0 or you get a proper answer. If you get a proper answer, then well and good, you got the answer. But if you got a 0 by 0, you have to follow other methods like factorization or rationalization, which you have learned in the previous classes. So for this, we will first directly substitute. So for direct substitution, wherever you see x, you just put the value 0. So root of 1 plus 0 minus root of 1 minus 0 divided by 0. So root of 1 plus 0 is root of 1, which is 1. So 1 minus root of 1 minus 0 is root 1, which is 1 by 0, which is equal to 0 by 0. So we got this 0 by 0 form. We know 0 by 0 form is not a valid form answer, so we have to do some other method. So here we don't see a possibility of factorization, but we see roots, so we can do rationalization. So how do we do rationalization? We multiply the numerator and the denominator with the conjugate of this rational numerator. So if we are doing by a rationalization method, I'll just write the method. So by direct substitution we got 0 by 0, so we can't do that. So by rationalization, limit x tends to 0 root 1 plus x minus root 1 minus x divided by x times, we multiply the numerator by 1 plus x plus root of 1 minus x and the denominator with the same thing, root of 1 plus x plus root of 1 minus x. Okay, solving this we get limit x tends to 0. This is a minus b into a plus b. A minus b into a plus b is a square minus b square. So we get root of 1 plus x whole square. So root and square will get cancelled. So 1 plus x minus, don't forget the bracket, root 1 minus x whole square. So root and square will get cancelled. So 1 minus x divided by x times root of 1 plus x plus root of 1 minus x, which is equal to limit x tends to 0. Opening this, we get 1 plus x minus 1 plus x. Minus 1 and plus 1 will get cancelled. X plus x is 2x. So 2x divided by x times root of 1 plus x plus root of 1 minus x. Now we try the direct substitution, see what answer we get. So we do direct substitution. We can get 2 times, wherever you see x, put 0. So 2 times 0. Oh, I'm sorry. So before the step, directly substitution, let's just go back a bit. Before doing that, we can see if we even substitute now, we get 0 by 0 because there's x and x here. If we put 0 here, this becomes 0. If you put 0 here, 0 times anything is 0. So we still get 0 by 0. But here we can do something. We can factorize, we can cut off these x's, so it doesn't result into 2 into 0. So I didn't notice that. So before you make the same mistake, make sure to cut everything off before you get the same 0 by 0 result. We don't want that. So limit x tends to 0, 2 divided by root of 1 plus x plus root of 1 minus x. Now we can directly substitute 2 by root of 1 plus 0 plus root of 1 minus 0, which is equal to 2 divided by root of 1 plus 0 is 1 plus root of 1 minus 0 is 1. So 2 by 2. So the answer would be 1. What did we do here? We actually first put the value direct substitution and found it was 0 by 0. Done. So we needed another method. We saw the root, so we did rationalization. Doing rationalization, we got the result as this. We can cancel off the x's, which results into 0 by 0. So cancelling those off doesn't make our answer a proper one, and we get the answer as 1. Second question. Limit of x tends to 0 sine 3x by tan 2x. So we see this is a trigonometric result. Trigonometric questions, limit questions. So limit x tends to 0 sine 3x divided by tan 2x. Okay. So we see here, if we do direct substitution, we write sine 3 into 0 is sine 0. Tan 2 into 0 is tan 0. Sine 0 is 0. Tan 0 is 0. So we get the form tan 0 by 0 form. So by direct substitution, we ruled out that. Now we know we can't do factorization here, nor rationalization since there is no root. So what else can we do? We have learned standard limit results. Some results which included sine and tan were limit x tends to 0, sine x by x is equal to 1. And another result, limit x tends to 0, tan x by x is equal to 1. So we have these two results. What can we make of these results to help us with this problem? So looking at these results, we see, let x be any angle. So we take x as an angle. So limit when that angle tends to 0, sine angle by angle is equal to 1. In the same sense, if we consider here, in this case limit, our angle in this case would be 3x. Okay, 3x is our angle. So angle sine 3x by our angle sine 3x by 3x, where 3x as a whole is the angle. So limit angle by 0, angle tends to 0, sine angle by angle would equal to our former result as 1 itself. So what did we understand? For any angle, here x is the angle, here 3x is the angle, but we don't multiply this by 3. That doesn't work like that. We just take 3x as the whole angle like we took for x. X is just an angle, 3x is also just an angle. So when angle tends to 0, for the expression sine angle by angle, the answer would be 1. In the same case for tan also, limit, here we have 2x, so 2x would be the angle. So limit 2x tends to 0, tan 2x, where 2x is the angle, by 2x, and answer would be 1. Okay. So here also the angle is 2x. So when angle tends to 0, for the expression tan angle by angle, the answer is also 1. So with these results, what can we do with this question? In this question, we don't have a 3x or a 2x. So we have to sort of create the x's in the denominator. So I'll show you how that works. Creating an expression is quite difficult, but I'll talk you through it. X tends to 0. Now we know from the algebra of limits, we can divide this limit into numerator and denominator. So limit sine 3x divided by limit, give the limit to denominator also, tan 2x. Okay, this is by algebra of limits which you have learned. And we have to create an x in the denominator. So what can we do? We can multiply the denominator and numerator with an x, right? Yes. So limit x tends to 0 sine 3x by x. We take an x in the denominator, and if we write an x here also, limit x tends to 0 tan 2x by x. Okay. So if we write x's in the denominator both here, they can just cancel out and we get the former equation. So we didn't pretty much do anything, we just added an x to help us form our way into this expression. And now what do we need? We need a 3 here, we need a 2 here. So what do? We multiply a 3 here and we put a 3 in the numerator. I'll put it outside because it doesn't really have to do anything with the limit. So 3 here and 3 here, if we cut it, it nullifies it. Here also we need a 2, so we put a 2 here, we put a 2 here, right? So what is this expression? This expression we just saw, it was 1. Limit x we can modify the limit, because x times anything is tending to 0 itself, because 0 times anything is 0. So here this limit evaluates to 1, which we have found. So 3 times 1 divided by 2 times, what is this? This is 1. This whole thing would be 1 according to our standard limit. So the answer would be 3 by 2. So we got the answer as 3 by 2. So in such questions, first split the limit and then form our way into this limit result by giving x and x wherever, but don't make sure to always check if they cut out and get the former equation, or else it'll be wrong. Here we added x because we can just cut it off and it doesn't really change anything, so we can add it like that. Here also we added 3, no, we multiplied 3 because we had a 3 here in the denominator which we added. So like that we can form our way to this standard result. Next question.